Hello. It's a real pleasure to be here talking about Nuxt and the Composable Web. My name is Daniel Rowe. I'm on the core team of Nuxt, which is a framework for building web applications. If you've not come across it, I'll tell you a little bit about it in a moment. I'm based in the UK. I'm here in the Northeast. I live on the banks of a river. I have 3 cats and a dog. And if you're ever in contact with me on Twitter or Discord discussing Nuxt or something like that, I'll probably be sitting here in my study with a mug of tea in my hand. My background is before I started work on Nuxt full-time, I headed up a small software as a service HR startup. And we built our tech stack with Nuxt. That was how I came to be involved with Nuxt. This is very much something that I have experienced as a user. And so as I start to talk a little bit about what we're trying to do and build with Nuxt, it's not just from an architect's point of view. It's not just from a framework's point of view. This is very much something that I've experienced, and these are pain points that I've hit myself. If you haven't come across it, as I said, Nuxt is a framework for building web applications. It's a progressive framework. So you can start a project with Nuxt and with no configuration at all, start building for the web. You can create pages in a pages directory. It's built using Vue, so you can use Vue syntax. And you'll find that automatically gets turned into a server-side rendered application for you. It's all kinds of best practice is baked in, from SEO to bundle splitting, optimizing page rendering time, speed. A lot of things just come out of the box if you're using Nuxt. And it's hugely, hugely extensible. So there's a whole ecosystem built around Nuxt. So Nuxt modules, for example, add all kinds of different features and functionality, integrations with different deployment targets, databases, CMSs, logging solutions, all kinds of things. You can check them out on modules.nuxtjs.org. And that's one of the things that's made Nuxt so attractive for lots of people who are building web applications. If you've used Nuxt before, you'll probably know that there are several targets that Nuxt is building for. So one of them is the server target, the bit that actually is running on a node server somewhere that returns that initial string of HTML. Then there's a modern browser and then a legacy browser build. And both of those run in the browser and hydrate that HTML and make it interactive and interesting, all kinds of things. So that's a little bit about Nuxt, and that might be what you've come across before if you've been using Nuxt or encountered it in your work. But things change, and things have changed since Nuxt has been created, particularly this year and the last couple of years. Trying to forget the massive pandemic that's taken place across them. What's happened in the tech world, particularly in the web world? And from my point of view, as the builder of a framework, some of the really interesting trends to look at are the rise of serverless architecture, the desire to see things just handling a clearly defined, a minimal as possible scope. So instead of worrying about maintaining servers, you worry about defining the code that you want to be running. I think of it much more functionally. Jamstack innovations. So the idea of applications that as much as possible are static. Now, with the dynamic part of them coming from APIs rather than necessarily from a monolith that puts everything together and returns a response. New targets are really interesting to see. So a bun is the new hotness. That's a delight to see. But also workers, things like Cloudflare or Netlify's or Versal's edge rendering solutions built on Cloudflare and Dino. Other things that are shaking up the ecosystem include things like ES modules, a big migration from CJS to ESM. And the industry-wide adoption of TypeScript. for better developer experience, and also a potential deployment target as well. And the focus on data, not necessarily HTML. But what isn't changing is the importance of fully rendered HTML, both from the point of view of a great user experience, because when you get an immediate response from the server and it contains elements, colors, images, everything that you would want to interact with and see, that's a lot better experience than if you're confronted with a loading screen. And that's why all kinds of companies, from TikTok, this is a clip from one of their websites, to Google, to plenty of others, are aiming for server-side rendered HTML. It gives a particular kind of speed, and it gives great, obviously, advantage from an SEO point of view. So I want to talk a little bit about how we've aimed moving to our new major release of Nuxt 3 to adapt to a changing world. So we've gone back to square one and thought about what do we need to do to build a framework that's going to be targeted for, aimed to thrive in this new and different world. And we decided to start with a new concept of a server. So we call it Nitro. It's a server, or we might also call it a next generation rendering engine, because it's not a server in your traditional sense. And our aim is to make something that can render a response anywhere. It can run on any target. So it's not pinned to a particular one. Previously, Nuxt was pinned to Node, for example. But the aim of Nitro is we can produce output that runs on Dino or Bun or workers, or in fact, even in a service worker in your browser. We also need to change what we're optimizing for. So in Nuxt 2, rather than have a server that starts once and runs for days, weeks, with Nitro, we want something that is optimized for a fast cold start for life in a serverless environment. And in fact, the whole thing about Nitro is about moving to the edge, to be as close as possible to the user who is actually experiencing the web application, and as fast and responsive as we can possibly make it. So Nitro offers quite a lot. It offers a zero config, multi-provider deployments, automatic API generation, code splitting and async chunk loading, all the kinds of things you would normally see in a client-side environment for the server, a storage and caching layer, and all kinds of innovations around static. So static generation, not just of pages, but also of API routes and all kinds of other things too. Let me tell you a little bit about how we make that happen, both for Nitro and therefore for Nuxt. So a big move that we've seen is a move to use rollup as a assembly mechanism. So Nitro is a two-stage build for us with Nuxt. Our first stage build is Vite or Webpack, something like that, produces a client bundle that contains all the view part of your application. But the second stage with Nitro is built on top of rollup and processes all of that output to turn it into something that is going to run quickly in an asynchronous manner on whatever target or platform you need. And so rollup has been a really good foundation for that. In particular, we built a library called unplugin that allows us to write code that can transform and process build outputs on rollup, but also on Vite and on Webpack. It allows you to write isomorphic plugins. So write one plugin, run anywhere, much as we're aiming for with Nitro itself. So we've done a number of things with that. For example, we've been able to add support for auto imports. We're able to declare to your editor what imports are available to you, what useful utilities there are, like defining a server API route, or common utilities to process cookies or deal with request headers, things like that. Your IDE knows they exist. You can simply use them, no need to import them. And then when you actually build the app, we inject the import in the correct location. So it's not globally available. It is only used where you use it. And we're able to do all kinds of clever things with dynamic imports, code splitting. So the code that you use is actually only loaded into memory when it's needed. So for example, if we hit the Nitro server for one API route, we won't load the code into memory that will handle the other API route, which means we can return a response incredibly quickly. And all of that is all powered by Rollup and its plugin architecture. We also built another tool called unenv. You'll notice, by the way, that some of these tools are in the GitHub organization un.js. It's a collection of lots and lots of different libraries and tools that we've built as part of this process that we don't really want to be tied to Nuxt. The aim isn't just to grow the Nuxt empire. Obviously, we want to make a great framework that people love to use. But for these libraries, the aim is to promote universal JavaScript. So JavaScript that you can write once, run anywhere. That is really isomorphic, can run on any platform and at any target, as much as possible, pure JavaScript. And already we're seeing adoption from other frameworks and projects. So do check out un.js and see some of the things that we've built there. But unenv in particular allows us to mock and stub dependencies that aren't supported in the target environment that we want to build the server for. So on a node-based environment, you can use all kinds of built-ins, for example. And there'll be dependencies that rely on those things. But if you're building for Cloudflare, which operates in a service worker-like environment, it doesn't have access to those node built-ins, but it has different kinds of things too. So we can create polyfills for those. And unenv is like a library of polyfills that lets us seamlessly produce output. You just flip a switch and it changes the kind of output that's produced. We also, because there are dependencies that are fairly big, that are routinely used in projects all around, dependencies of Vue, for example, and other key dependencies in a Nuxt project, we've been able to polyfill those and stub them out with much, much smaller equivalents, and actually do this at the Nitro layer. So we are able to produce something that's much, much smaller than would be true otherwise. And all of that is through unenv. So again, feel free to check it out. It adds support for lots of things, and some that I haven't even mentioned, such as our cool isomorphic fetch, but more on that in a moment. And what's more, we've adopted a tool called NFT. Not that kind of NFT, but Versal NFT. It's a fantastic library. It basically lets us detect not just what packages are used by your built server, but actually what files within those packages are used. We can actually trace the dependency tree based on what you're using. So that means not only can we get rid of things like readmes and that kind of cruft that might be in your node modules, but we can actually narrow it down to just the source files that are actually required to run your application. That means we can deduplicate dependencies, and we produce a node modules folder that accompanies your Nitro server that only has the files that you actually need to run that server, to run that application. And that is a phenomenal and hugely, hugely beneficial tool for our aim, which is to create a server that is ultra minimal, that is built for the edge, will be fast to start and fast to run. So this is, for example, the total output of a Nitro build with Nuxt. That's all the node modules that we actually need to have. It fits on a tiny screen. That's it. And just the files in each node module that are actually required to run the application. What that means is we were able to go from, this is a bare minimal app in Nuxt 2 versus Nuxt 3, from 51 meg of node modules dependencies on Nuxt 2 to 716 kilobytes on Nuxt 3. And that's all powered by Nitro. It's the same level of app, the same level of feature and integration, but a vastly, vastly different size. And it's going to make a huge difference with a serverless application for lots of reasons. Not only is it likely to be faster to load into memory, it's going to be faster to unzip if you're thinking about a serverless function that has to be unpacked, and that makes a huge difference. And the space is not infinite, so often you're dealing with a 20 or a 50 meg limit for some kind of endpoint. And so it makes a huge difference, this work that we've been able to do. But that's not all. We also want to avoid hitting the network layer at all if we can. It's one of the most expensive parts of a server-side rendered app is the API requests. And whenever people experience a slow response, the first step is always to see, well, what requests are you firing off? What requests are you actually making as part of your render? As much as possible to cut those down, or to ensure that you're serving it from the same region as the actual database that you're querying, or whatever it might be. But in particular, we can completely eliminate network requests that are from one endpoint to another within the application. So you might have this, of course. You might have an endpoint in your Nitro app that serves one kind of response, and to render the HTML of your app, you might actually need to know what the response is, what that output is. Well, we have the concept of an isomorphic fetch function. We've built it using omyFetch and unenv. omyFetch is a fetch API compliant library, which also outputs something called $fetch, which is incredibly handy. No need to JSON stringify things, no need to JSON parse them, it's all done automatically. But working together with unenv, we can actually mock network requests. So we can perform what look like network requests. So it adheres to the fetch API, you specify an endpoint. If that happens on the browser, it makes a proper network request. It hits the layer, hits the server, gets a response. If it happens on the server, we mock a network response. We mock a request and response object, and we actually go through a little bit of the life cycle, but much, much faster than if we had actually had to hit the real network layer. So instead, we just load the handler function, run it, and return the response just as though we had called a function. That is a huge performance savings and opens the door to lots and lots of benefits from the Nuxt and Nitro point of view. We're also moving with Nitro to a more DX-focused framework with performance implications. So rather than thinking, again, of a monolithic HTTP framework with everything built in, maybe accessible as properties on an object or methods, we've adopted a more composable, tree-shakeable framework. You import the functions and capabilities that you need. If you don't need them, they can be tree-shaken out. And we've moved from the traditional node request response object to more intuitive idioms. So rather than needing to do things like set headers when you're returning JSON, you can just directly return an object, and H3 will take care of transforming that object into a string, adding the correct headers, and returning a response correctly. We also are moving towards an event-based model. So even though you have access to the underlying request and response objects, which may well be the case on Node, you can actually interact with something which is an event and is much more intuitive in terms of thinking about how you respond. The whole thing is built for minimal friction, not just from the point of view of the developer who's building the app and actually using these abstractions, but also from the point of view of thinking about what this gets turned into on the point of view from the point of view of the actual server output. And then, of course, another thing that we can do, we can move expensive operations to build or generate time. We're not talking about a server that's running for weeks and months at a time and needs to cope with files being uploaded by FTP to some public directory. We can actually do a lot of the work in advance because it's deployed at some point. It's then not going to change. We can generate e-tags. We can decide what MIME types even need to be part of the server bundle. And that means we can actually generate a manifest with that kind of information so the server can return that response immediately rather than needing to calculate it dynamically. We also have the ability to use root rules for hybrid sites. So out of the box today, a Nitro application can have some pages that are generated in advance, static JSON, static HTML. They can have some pages that are use a stale revalidate strategy that might be cached for some period of time and then revalidated when necessary, or never revalidated, perhaps. Maybe it only runs at one point in time. And some that are fully dynamic and called at every request. So you can create hybrid sites, and there are more features and enhancements on the way. We're pretty excited about some of the things we're building from this point of view. But as much as possible, we'd like to move things that don't need to be runtime to be build time. So if you can create a static site, or a site that will be static as soon as it's hit once, with an incremental static regeneration strategy, then that is absolutely something that we want to do with Nitro. And so we're building a framework that allows us to do that. That means, so here are the implications for us from Nuxt's point of view. Again, this is a out-of-the-box application. From the moment you run, from the moment the first JavaScript file is passed to the moment the server is ready to receive a response. Nuxt 2, 314 milliseconds to start. Nuxt 3, 3 milliseconds. And if you start a new Nuxt app, that is the cold start you can expect. Anything beyond that isn't Nitro, it's the actual application code. That means this is actually feasible to build an edge-rendered HTML SSR rendered application on the back of. Using Nitro, Nuxt can run in your browser service worker, can run on your CDN, can actually be the kind of response that you get that the user doesn't even notice that it's taken time. So we're pretty excited about that. The actual response, rendering the response, takes something like 20 milliseconds, on top of that 3 millisecond cold start, to give you an idea of the numbers we're working with. And we want this to work everywhere. We don't want it to be tied to a particular framework or platform. I mean, I'm a big fan of interoperability. I think personally, it should be platforms' ease of use, or features, or customer service. What that platform offers, that is what drives people there, rather than vendor lock-in. And we've built that with Nitro. So using another package we've created called standard and env, we allow auto detection of the framework or platform that you're actually running on. What that means is, without needing to configure your application at all, we can detect what output is needed. So for example, if you're running in an Azure Static Web Apps build pipeline, we can detect that. We can create the right directories and folders, generate the Azure functions that are required, and put the static files in the right folder. If you're running on Cloudflare, we can detect that. We can output a single worker style output and put it in the right folder. And the same goes for Firebase, where we'll also generate your Firebase config file, or Versal's new file system API, or Netlify's, again, you have to create a .netlify file. All of this we figure out based on the environment. And as much as possible, it means the user doesn't have to make any configuration. It just works out of the box. And that's the aim. Cross-platform, out of the box, zero config. And these are either all zero config, or we are doing as much as possible to make them zero config, working with providers to make that possible. So out of the box, and we already have some zero config. Actually, I think I might need to update this slide. We have more zero config providers already. But everything that you see is there's already zero config or has minimal configuration required. And it's possible to build your own presets. no extra steps required. It can all be configured within your Nuxt config or Nitro config. And then if your preset is great, either bring it into Nitro or you can ship it as an independent library. We want the doors to be open here for presets to be built for any deployment target or deployment platform. The whole thing means the CI/CD pipeline that you'll be going through with a Nuxt or Nitro app is incredibly fast and responsive from the deployment point of view. So on the projects that I've been deploying, I routinely see entire testing CI/CD processes taking less than a minute, 40 seconds or so to build, generate, test, and deploy with a serverless output at the end. It's a pretty cool experience. I hope you jump in and actually see what it's like. If you're interested and you want to take things further, see what Nitro can enable from the point of view of a dynamic, edge-rendered web app, then check out the docs. Nuxt 3 is in release candidate status at the moment. You can find the docs on v3.nuxtjs.org. Nitro is a standalone project. You can use it either as part of Nuxt or on its own if you have a use case for that. Check it out at nitro.unjs.io. Follow Nuxt.js on Twitter or me, and feel free to join on the Nuxt Discord. There's a really active community that would be happy to answer any questions you might have. And of course, you should feel free to ping me if I can be of any help at all. I can't wait to see what you build with Nuxt and Nitro.
Hey, thank you so much for watching that. I really hope you got value from it. By the way, if you want more where that came from, go to composability.dev and register to be a part of our community today. And if you want to be even more part of our community, go to Twitter and look up JavaScript Jam and follow us. Every Wednesday, we go live at 12 p.m. Pacific Standard Time, and we talk about anything and everything web dev. It's an open mic for everybody, whether you're a beginner, whether you've been doing this forever. We'd love to hear from everybody, and there's always so much value and good conversation going on there. We wanted you to be a part of it too, so come join us. And by the way, if you left a comment below, that's exactly where the comments are going to be answered during the live Q&As with the speakers. JavaScript Jam live on Twitter Spaces. All right, go to JavaScript Jam. Do it now. Follow us. All right, see you soon.